We're going to review for the final. Today's review will include chapter 10, and next time we'll do chapter 11. So by next time, hopefully everyone is done with the homework and the stuff in chapter 11. Chapter 10, what do we have in chapter 10? We have the parametric, mostly the polar, and how we apply them, parametric and polar. So we take the parametric first. What do we need to know in parametric? Is we need to learn how to find the slope basically, which is dy dx, or derivatives. That's dy dt, dx dt, provided that the denominator is not zero. The second derivative with respect to x is basically the derivative of the first derivative, and that would be the derivative of dy dx with respect to t and dx dt. So we can ask find dy dx and d square y dx square for the curve defined by x equals t plus sine t and y t minus cosine t. So dy dx is dy dt dx dt. Derivative of y with respect to t, it's 1 plus sine t over 1 plus cosine t. Now the second derivative, d dt of dy dx divided by dx dt. So the derivative for the one we just found, we use quotient rule. We take the denominator times the derivative to the top, which is cosine t, minus the top times the derivative to the bottom one. Over dx dt, which we already found earlier was 1 plus cosine t. After simplifying all of this, make sure this is 1 here, so in the denominator we're going to get 1 plus cosine t all to the third power, right? And then on the top we just distribute this out, cosine t plus cosine squared t plus sine t plus sine squared t. And notice sine squared plus cosine squared is 1, so we're going to have 1 plus cosine t plus sine t all over 1 plus cosine t to the third power. That's the max we could simplify. Good to know on the top of this, good to know the arc length. Arc length L is given by the integral, if you are working on an interval alpha to beta, let's say, square root of dx dt square plus dy dt squared dt. So again, this is the curve is described by, provided that the curve is described by the parametric x equals f of t, y equals g of t, like so, over the interval alpha to beta. So that gives me the length of the arc. This gives me the length of the arc traced by this curve over alpha to beta. Over alpha to beta. And we have f prime and g prime continuous on the same interval alpha to beta. Find the length of the arc or the curve defined by x equals 3t squared, y equals 2t to the third over the interval 0 to 2. So first you can find dx dt if you like, which is 6t, and dy dt 6t squared. Then the arc length is the integral from 0 to 2, the square root of the first one squared, the second one squared, dt. This equals to the integral 0 to 2, 36t squared, 36t to the fourth. Then we factor 36t squared comes out as a 6t, and that will leave 1 plus 6t squared, or well, we factored 36t squared, so that will leave t squared. Now to integrate this one, we can use the u sub, right? We can use the u sub. So on the side, if I want to do it, I want to do the 6t squared of 1 plus t squared dt. U equals 1 plus t squared. So du is 2t dt. So this becomes 3 outside and 2 in, 3 times 2. So the 2t dt is du. This is square root of u du. So 3u to the 1/2 du. Then 3u to the 3/2 times 2/3. So 2u to the 3/2. So that is gonna go into this one, and we write that down. 2u is 1 plus t squared to the 3/2 from 0 to 2. Then we substitute the 2 in. 2 squared 4 plus 1 5, 3/2 minus 2 times 1. And this could be rewritten as 5 square root of 5, so you get 5 times 2, 10, or you can keep the 2 out, whatever you like. 5 square root of 5 minus 1, like that. More examples on this. Find an equation of the tangent line to the curve defined by x equals sine pi t, y equals t squared plus t at the point 0, 2. So to find the equation of the tangent line, we need to find the slope, right? dy dx. dy dx is dy dt over dx dt. dy dt is 2t plus 1, and the derivative of sine pi t is pi cosine pi t. Then the slope of the tangent line is going to be this derivative at t equals some value. So how do we find the t value? Remember, we can set the sine pi t equal to 0 and the t squared plus t equals 2. So if we solve the second equation by factoring t plus 2t minus 1, we would get t to be negative 2 or t to be 1. So now if I take t to be 1 and plug it in there, you get sine pi, which will give you 0. That's okay. And same thing with negative 2, sine negative 2 pi, which is back to 0. So let's start with t1. Substitute into the answer we got above. 2 times 1, 2 plus 1, 3 over pi cosine pi. Cosine pi is negative 1, so that gives me negative 3 over pi. If I try also, I'm going to find dy dx at t equals negative 2. Substitute in, you're going to get negative 4 plus 1, negative 3 over pi cosine negative 2 pi. Cosine negative 2 pi is 1. So I'm getting the same slope. So now we have the slope of the tangent line, negative 3 over pi, and the point, the given point 0, 2. We use y minus y1, slope times x minus x1. And you may simplify it by rewriting it like so. So that was about parametric stuff. So basically you need to know, everything was covered in class, but those are very important. For polar now, for polar coordinates, first thing in polar, good to know the relation between polar and rectangular. X squared plus y squared is r squared. X equals r cosine theta, y equals r sine theta. And tan theta is y over x. Next thing good to know is the polar sketch, the sketch of the graphs. The graphs that we covered in class, all of them, but focus mainly on r equals cosine theta, r equals sine theta. You know, those ones, they are circles, right? If you want, you can put A, those are circles. Also, the a plus b sine theta, a plus b cosine theta, where a and b are the same, and that's called cardioid. So those are the most important ones. So how would they ask a question on this? Maybe we can apply this. The reason we need to know the sketch, because they can ask you questions about the graphs. related to graphs like area. So the area, formula for the area in polar, it's 1/2 the integral from alpha to beta. We take the function, we square it, d theta. And remember, f of theta is the same as r. So if you write it this way, or you make it r, or r squared, it's the same. Now we can look at an example. Maybe find the area of the region bounded by the graph r equals 2 plus 2 sine theta check sine, because a and b are the same, that's going to be cardioid. Sine is either up or down. Because the middle sign is plus, is going to be up. So the cardioid is going to go this way, up, down. So that's about 2 units, 4 units up, 2 units to the left. So we were asked to find the area of this whole thing. By the formula, it's 1/2 the integral from alpha to beta. So there's many different boundary limits you can put. One of them, you can start at 0, and then it goes all the way to 2 pi to cover everything. And then here is the r square, which is 2 plus 2 sine theta square, d theta. So then keep the 1/2 out, 0 to 2 pi. You can factor 2 out and square, that makes it 4. 1 plus sine theta all square d theta. So the 4 will come outside, make that 2. And then here we need to square this, 1 plus 2 sine theta plus sine square theta d theta. We need to know the formula for sine square to help with integrals. 1 minus cosine 2 theta, 1 minus cosine 2 theta divided by 2. The area becomes 2 integral 0 to 2 pi 1 plus 2 sine theta plus 1 minus cosine 2 theta all over 2 d theta. A equals, if you multiply the 2 in, you would be getting 2 here plus 4 sine theta plus 1, which I can add it to the other 2, becomes 3, minus the cosine 2 theta. Now I simplified everything. I need to integrate this one. Integral of 3 is 3 theta. This is negative 4 cosine theta minus 1/2 sine 2 theta from 0 to 2 pi. Then we substitute the 2 pi, that becomes 6 pi minus 4 cosine 2 pi. Cosine 2 pi is 1 minus 1/2 sine 4 pi, which is 0, minus, for the 0, that's a 0, minus 4 cosine 0 is 1. So the answer becomes 6 pi. The arc length in polar. The formula for the arc length in polar is L equals A to B, the square root of r squared plus dr d theta square d theta. So this is the length of the arc with polar equation, with the equation r equals f of theta, where theta is changing from A to B. One thing we use all the time, also recall the one I use, that sine squared theta is 1 minus cosine 2 theta divided by 2, and the cosine squared theta is the 1 plus cosine 2 theta divided by 2. Those are very important when it comes to integrating sine squared and cosine squared. If r equals f of theta, then in polar we can, to find the slope dy dx, the formula we proved in class, it's f prime of theta times sine theta plus r or f of theta cosine theta divided by f prime of theta cosine theta minus f of theta sine theta. Find the slope of the tangent line to the curve. R equals two plus sine 3 theta at theta equals pi over 4. So first we need to find r prime or f prime of theta, 3 cosine 3 theta. Then dy dx is, the derivative is 3 cosine 3 theta times sine theta plus 2 plus sine 3 theta times cosine theta. The derivative is 3 cosine 3 theta times cosine theta minus the function itself times sine theta. At pi over 4, we just substitute pi over 4 for theta. So you get 3 cosine 3 pi over 4 sine pi over 4, 2 plus sine 3 pi over 4 cosine pi over 4, 3 cosine 3 pi over 4 cosine pi over 4, 2 plus sine 3 pi over 4 sine pi over 4. Negative square root of 2 over 2 sine pi over 4 square root of 2 over 2, 2 plus sine 3 pi over 4. Okay, so the sign is going to be positive, which is square root of 2 over 2 times cosine again square root of 2 over 2. 3 times the cosine is negative. This is positive minus 2 plus root 2 over 2 times root 2 over 2. You could cancel, like multiply the top of each one of them to cancel all of this. And that would give us negative 3 root 2 over 2 plus 2 plus square root of 2 over 2. Negative 3 root 2 over 2 minus 2 minus square root of 2 over 2. Then probably multiply top and bottom by 2. That will clean up the fractions. Negative 3 square root of 2 minus 4 minus square root of 2. Combine like terms, negative 2 root 2 plus 4 over negative 4 root 2 minus 4. And I would divide top and bottom by 2. Rationalize. So negative